So in part A here, a point -4, 3 is on the terminal part of an angle. We are trying to find theta. Again, start with drawing your triangle. Where is -4, 3? What quadrant would that be in? It's in quadrant 2. Over 4, up 3, there's our point, -4, 3. And if we drew a triangle to our nearest x-axis, there's our reference angle. We are trying to find the angle in standard position, so we're looking for this angle, because that would be the angle between 0 and 2 pi. We're also going to be looking for this angle, because the domain that they give us is from -2 pi to 2 pi. So again, if we break it up into its positive parts and its negative parts, the positive part we're looking from 0 to 2 pi, and the negative part we're looking from 0 to -2 pi. Well, what do we know about this triangle? What lengths do we know? We know this side here is 4, and we know this side is 3 because of the point that we were given. And so if I want to find that reference angle, since I know the opposite side and the adjacent side, I would use tan. So once again, you wouldn't need to do a squared plus b squared equals c squared. We don't need to find the other side. By the way, does anybody recognize the other side? It's 5. It's one of those fancy triangles. Remind me, I can get off topic about fancy triangles when we're done this question, but we'll finish it first. So we've got tan of our reference angle is going to be 3 over 4. And once again, I'm just thinking about an actual triangle with actual lengths, so I'm dealing with all positive values when I'm finding my reference angle. Go to my calculator, do tan inverse of 3 over 4. And the other thing to notice here, in our domain was given in radians. That's telling you to solve your question in radians. So I need to, also it says to the nearest tenth of a radian. That's also a hint that you need to be in radians. But when your domain is given in radians, we need to make sure that we solve in radians. Our calculator was already in radians from before. So when I do tan inverse of 3 divided by 4, I get a reference angle of 0.644. And again, I'm going to keep all of those decimal places right until the end and only write my answers to the nearest tenth at the end. So again, on my calculator, since I know I'm going to be using this reference angle more than once, I'm going to store it as x just so that it's handy and easy to use. So now when I look at my diagram here, if I'm thinking of solving all of my positive angles, which go from 0 to 2 pi, how would I solve that green angle? Well, if I was dealing in degrees, I'd do 180 minus my reference angle. Now I'm switching over to radians. I'm going to do the same idea, but it's going to be pi minus my reference angle. So go to my calculator. Pi minus my reference angle, which I stored as x. And I get 2.49 rounded to the nearest tenth will be 2.5. When I look at my negative angles, that's going from 0 backwards to -2 pi. Once around the circle in the negative direction. Whenever I'm doing my negative angles, I think of positive numbers and then I just write the negative answer in the end. Can you see that going up to here, is like traveling 180 degrees or traveling pi, and then we're going to have to go another reference angle further. So as far as what I put into my calculator, I'm not worried about the negative right now. I'm just thinking that distance is pi, and I'm going to another reference angle further. So when I type it in my calculator, I say pi plus my reference angle is 3.78. That's how far it's traveled. But when I go to write my answer then, that angle would be negative 3.8. And so now we've solved for all the angles between negative 2 pi and 2 pi. Again, we found our reference angle first. We had our diagram to see so we could see which angles we needed to solve for. And then we could write out our answers. Part B, given cotangent is negative 2. Again, we're solving between negative 2 pi and 2 pi. Well, if I have cotangent of theta is negative 2, always as a first step, whenever you're given one of the reciprocal functions, write its reciprocal out. Cotangent is negative 2. Tangent will be the reciprocal negative 1 over 2. Then you can draw a triangle. What quadrants could this happen in? Tan is negative in quadrant 2, and tan is negative in quadrant 4. Again, each time you draw your triangle, it goes back to the nearest x-axis so that you have your reference angle. Tan is opposite over adjacent. So the opposite is 1, the adjacent is 2. So this is what your triangle looks like for both of them. For solving our reference angle is always figuring out with positive values. So even though tan is equal to negative 1/2, tan of the reference angle will be positive 1/2. Again, our calculator is already in radians. 0.46. Again, I'll keep all of those decimal places. Now going back to our picture and thinking back to our original domain. It's one of the things that you're always going to check when you do these kind of questions is once you've got your reference angle, look back to the original question and say, what was the domain? Where do they want me to solve from? And in this case, we're going to solve for all the angles between negative 2 pi and 2 pi. If we think back to our diagram, that means we're going to have positive angles from 0 to 2 pi. What are they going to look like? I have one positive angle that will go to there. I will have another positive angle that will go to there. And I'll have all the negative angles from 0 to negative 2 pi. So that means I'll have one negative angle here and another negative angle there. So if we want to find our positive angles first, those will be the ones from 0 to 2 pi. Well, the first one is in quadrant 2. Again, if you were doing in degrees, you'd go 180 degrees minus your reference angle. Now we're dealing in radians. We'll do pi radians minus our reference angle. I'm going to be using my reference angle a lot. So again, I'm going to hit my store button and store it as x so that I can use it quickly. And then in quadrant 2, pi minus my reference angle will be 2.7. Did it say to the nearest tenth? Yeah. So one positive angle is 2.7. The other positive angle If I was dealing in degrees, I would do 360 degrees minus my reference angle. Now I'm dealing in radians. Instead of 360, I'd have 2 pi minus my reference angle, which is 5.8. We still have to do our negative angles from 0 to negative 2 pi. Well, our first negative angle is just the same as our reference angle. And so our reference angle is negative 0.46 rounded to the nearest tenth. That'll be negative 0.5. Our second one would go, if we were thinking in degrees, you would think, well, it's 180 up to here, so if I did 180 plus my reference angle, that would be my angle. Now that I'm dealing in radians, I can go pi plus my reference angle, 3.6. So this angle will be negative 3.6. So unlike the one where before, you won't get a ton of word problems on your final exam, but you will get lots of questions like this. So make sure that you practice questions 13 and 14